Hello friends, today we are going to see the different applications of the first law of thermodynamics. गेल्या वेगवेगळ्या व्हिडिओमध्ये आपण फर्स्ट लॉ ऑफ थर्मोडायनामिक्स काय आहे हे आपण डिटेल स्टडी केलेले आहे. बरोबर. आपण इथं परत एकदा फर्स्ट लॉ ऑफ थर्मोडायनामिक्स नेमकं काय रिलेशन पाहिलं आहे आपण थोडंसं परत एकदा बघू आणि मग त्याचे ऍप्लिकेशन्स वेगवेगळ्या जे आपण थर्मोडायनामिक प्रोसेसेस बघितली मागच्या व्हिडिओमध्ये की आयसोबारिक, आयसोथर्मल, आयसोकोरिक अँड ॲडियाबॅटिक याच्यामध्ये फर्स्ट लॉचा कसा वापर होतो हे आपण आता बघूया. फॉर दिस स्टुडंट consider one system of gas in a cylinder. So this is frictionless cylinder, frictionless piston. So now this gas consists large number of particles, molecules. For simplicity, suppose that gas is the ideal gas. बाकीची कॉम्प्लिकेशन्स निग्लेक्ट करण्यासाठी आपण कन्सिडर करूया की गॅस इज अ आयडियल गॅस. आयडियल गॅस असेल तर आयडियल गॅस इक्वेशन यू नो दॅट PV is equal to nRT. And for 1 mole of gas, PV is equal to RT. So this is the general gas equation we are going to use here, where N is equal to 1. N is equal to 1 mole of the gas. 1 मोल गॅस असलेला गॅस आपण या सिलेंडर मध्ये भरलाय. 1 मोल म्हणजे तुमच्या लक्षात आलं फॉर 1 मोल ऑफ गॅस Avogadro's number is equal to 6.023 into 10⁻⁻³ molecules per unit volume. For now we are going to change the different types of the energies. If we provide certain amount of heat energy to the system, then consider the changes in the state of the system for different the state variables. So when you provide certain amount of energy, external heat energy specifically, is given to this state, then some amount of energy is increased, internal energy is increased, and other amount of energy will push this piston towards the upside. So that now the piston becomes like this. So here there is change in volume, that is dV volume increased. Initially that volume may be, we suppose that V, pressure is P, dV is a volume, and T is a temperature, and dU is its internal energy. So now if you provide dQ amount of heat energy to the system, then out of this dQ amount of energy, some energy is utilized to increase its internal energy, and some energy is utilized to do some external work. So we know the first law of thermodynamics. I will write first here the first law, dQ is equal to du plus pdv. हे जनरल इक्वेशन आपण वापर करू शकतो. आपण मागच्या व्हिडिओमध्ये तुम्ही म्हणाल सर du is equal to dq plus pdv म्हटलेलं. That is also correct. But when you write such type of equation, you have to define each and everything. So dq is amount of energy given to the system. du is amount of energy, internal energy increased. And pdv means what? Pressure into displacement, that is dw. I think you may write dw first of all, and then the work done is equal to pdv, that is force into displacement, nothing but pressure into that the increase in volume, that is pdv. So we can write the total that the pdv, this is the work done. So dq is equal to du plus pdu. So all these terms have specific meaning. You know the meaning of that. Already in last video you have confirmed that what is dq, what is du, is it plus or minus, what is work done, is it plus or minus, and why it is plus or minus, is it? So this is the total overall what we write, that is the first law of thermodynamics. Now we are going to change this state of the system differently. Suppose first change is isothermal change. First change is isothermal change. What will happen for the isothermal change? You know that for isothermal change, if decay amount of energy is supplied to the system, temperature remains constant. That means there is no change in its internal energy, but all the amount of decay amount of energy is utilized to do some external work, mechanical work. That means for isothermal change, T is constant. T is constant. T constant means dt is equal to what? dt is equal to 0. Is it? dt is equal to 0. So this first law now what will it becomes? So that is dt is equal to 0 means du is also 0. Because why? du is a measure of, that is T is a measure of internal energy. So now dq is equal to, it becomes, this equation becomes dq is equal to pd. So what it tells that amount of energy provided, heat provided to the system is utilized to do external work. So this, the heat provided, heat absorbed by the system is utilized to do some external work. So this is the change takes place, or the process takes place in isothermal change. Now suppose the second change we are going to study, that is the isobaric change. Isobaric change. What do you mean by isobaric? Isobaric means pressure remains constant. Pressure remains constant means volume may get changed, temperature may get changed. Is it? So when the decay amount of energy provided to the system at constant pressure, then we can define one term. That is here, first of all we have to write that pressure is constant. Pressure is constant. Pressure constant means change in pressure is 0. Change in pressure is 0. So now, for this condition, you have to define first this specific heat. According to the definition, the amount of heat required to raise the temperature through 1 Kelvin at constant pressure is known as the specific heat at constant pressure. म्हणजे काय, की प्रेशर कॉन्स्टंट असताना व्हॉल्यूम चेंज होऊ शकेल इंटरनल एनर्जी वाढल्यानंतर. So the amount of heat energy required to raise the temperature through 1 Kelvin at constant pressure is known as specific heat at constant pressure. So we can write that Cp is the specific heat at constant pressure. So that is the amount of heat, that is dQ divided by the change in temperature, or change in temperature is 1 degree Kelvin. So this equation gives rise to Cp dt is equal to dQ. Cp dt is equal to dQ. Now, for this Cp dt is equal to dQ means this equation, first law equation, changes to dQ is equal to du plus pdt. So now put the value of dQ as Cp dt. So now this equation will becomes Cp dt is equal to du plus pd. So this is the equation called as heat equation of the first degree, or specific heat at constant pressure. Isn't it? So now this is the one relation. One more relation we can study, that is the isobaric change, isochoric change, isochoric change. For isochoric change, already you know that the change in one state to another state at constant volume, volume remains constant. So now here, if volume remains constant, this volume constant, then change in dV is 0. So now we can write that V is equal to constant, means dV is equal to 0. dV is equal to 0. So now, for this dV is equal to 0, you will give rise to, if you are providing certain amount of heat energy to the system, then what will happen? You have to define this second term once again for isochoric change. So I will write first once again, same sentence. The amount of heat required to raise the temperature through 1 Kelvin at constant volume is called specific heat at constant volume, that is defined as C. So when volume is constant, you are going to provide the certain amount of heat energy. The amount of heat energy required to raise the temperature of its gas by 1 degree Kelvin, how much amount of heat required is called as specific heat at constant volume. So that means Cv is equal to dQ divided by dt. Again. So for this, we get dQ is equal to Cv dt. Isn't it? dQ is equal to Cv dt. So now the first equation becomes, first law of equation becomes dQ is equal to du plus pdv. So dQ is Cv dt, that is equal to du plus pdv. This is the relation for the specific heat equation for isochoric change. If volume is constant, then there is no work done. Work done is 0. So that means dV is equal to 0. So you can write Cv dt is equal to du. So this is the relation one can write for, because dV is equal to 0. Already we have supposed. So this relation is the relation for heat energy for isochoric change. And last one change we are going to write, that is adiabatic change. Adiabatic change. So for adiabatic change, there is no heat energy coming from the outside and no heat energy going to the outside. To increase the internal energy, we have to do some work on the gas or by the gas. इथे adiabatic change म्हणजे काय आहे? The change in the state one to another state at constant entropy. Entropy constant means there is no absorption of energy from the outside or given to the outside. So dQ, change in energy is 0. So for change in energy is 0, that means to increase its internal energy, you have to do some work. So all of you know that the internal energy of the system can be changed by 2 ways or 3 ways. Already we have stated it. That means by doing some work, one can change the internal energy. By giving some heat, one can change the internal energy. Or by doing or adding or taking out the number of particles, we can change the chemical composition, we can change the internal energy. So these are the 3 ways. But for the closed system, there is no exchange of matter with respect to surrounding. And hence, there are only 2 ways, that either you have to provide the heat or you have to do the some work. म्हणजे समजा तुम्हाला हाताला थंडी लागत असेल, तर थंडी लागत असेल तर हात गरम करण्यासाठी आपण काय करतो? एकतरी हात आपण एकमेकावर घासतो गरम. इट विल गेट द एनर्जी ड्यू टू फ्रिक्शन. सो वी आर गोइंग टू डू सम एक्सटर्नल वर्क. We are going to do some force and the frictional force and the displacement. So this will change the internal energy. This is one way. Another way, तुम्ही समजा इथं शेकोटी पेटवलाय आणि शेकोटीला हात तुम्ही धरला. याचा अर्थ काय होईल? शेकोटीला हात धरला असेल तर काय होईल? की तुम्ही हीट एनर्जी त्यांच्याकडे मिळवताय. म्हणजे हात आपल्याला गरम करायचा आहे, याचं इंटरनल एनर्जी चेंज करायचं, या हाताची इंटरनल एनर्जी चेंज करायची. एक तरी आपण घासून इंटरनल एनर्जी करतो म्हणजे वर्क डन करतो, आणि दुसरं बाहेरून एनर्जी घेतो, याचा अर्थ इथं प्रोव्हाइडिंग एनर्जी. बाहेरून एनर्जी म्हणजे शेकतो. पण या सिस्टीम मध्ये तुम्हाला बाहेरून एनर्जी घ्यायची पण नाही आणि बाहेर एनर्जी द्यायची नाही. सो चेंज इन एनर्जी, दॅट इज dq, इट मस्ट बी इक्वल टू 0. When this is 0, then what will happen here? That is d, that is du. dq is equal to du plus pdv. That is 0 is equal to du plus pdv, or du is equal to minus pdv. So change in internal energy takes place when work is done against or work is done by the system. ऑटोमॅटिक जर समजा याच्यामधून काही चेंज झालेलं नाही, काही आपण एनर्जी दिलेली नाही, तर पिस्टन इथपर्यंत मूव्ह झालं इंटरनल एनर्जीमुळे, तर याचा व्हॉल्यूम वाढेल. व्हॉल्यूम वाढला की टेम्परेचर कमी होईल, म्हणजे एनर्जी कमी होईल. कमी झालेली एनर्जी इज युटिलाइज्ड टू डू सम एक्सटर्नल वर्क. सो दॅट मीन्स du is equal to minus d. Minus because it decreases. So these are the applications of first law of thermodynamics. First law, we know that this is first law. For isothermal change, this is the relation. For isochoric change, baric change, this is the relation. Isochoric change and adiabatic change. Now we are going to study the relationship between specific heat at constant pressure and specific heat at constant volume. म्हणजे वेगवेगळे चेंजेस आपण स्टेट्स बघितले. One state changes to another state. System remains same, but their state variables changes. Then you can change the state variable in 2 modes. One at constant pressure and another at constant volume. So already the relation from the application of first of thermodynamics, we have derived that Cp dt is equal to du plus Pdv. हे relation आपण already मिळवलेलं आहे. So that is the heat energy equation for first law for isobaric change. Now for second, that is the Cv dt, यही relation आपल्याला मिळते, that is equal to d. This is the heat energy equation for isobaric change. So already we know the two relations. One relation for specific heat at constant pressure and specific heat at constant volume. Now put the value of du in this equation, you will get that Cp dt is equal to Cv dt plus Pdv. So now rearrange this. Cp minus Cv into dt म्हणजे काय केलं मी, ही जी टर्म आहे ही टर्म या बाजूला नेली, मायनस होईल, त्यातून कॉमन dt dt बाहेर घेतला, Cp minus Cv राहिला dt, so that is equal to Pdv. Equation number 1. For ideal gas, you know the relation for 1 mole of gas, that is Pv is equal to RT. At constant pressure, dP is equal to 0, you know that. P is a constant, so change in pressure is 0. So now if we differentiate this equation, then you will get constant, that is P constant. Differentiation of V is dV, that is equal to R is also constant and dt. So now we can substitute the value of Pdv is equal to RdT, equation number 2. So Pdv च्या ऐवजी इथं Pdv च्या ऐवजी RdT तुम्ही सबस्टिट्यूट करता. So substituting equation 2 in equation 1, we get Cp dt, Cp minus Cv into dt, that must be equal to RdT. Here dt cancel will, so you will get the relation, that is the famous relation Cp minus Cv is equal to R. So this is the relation between the gas constant and the specific heat at constant pressure, specific heat at constant volume.